Hello, good morning, good afternoon, good evening, whatever time zone you are in. Welcome to our first webinar of the year for deep dive into 3.9 features for the agent observability and quality. Joining me today, my name is Jules Damji. I'm part of the developer relations team. And joining me today is our esteemed team members from the MLflow team. We've got Serena all the way from Singapore, Yuki from Japan, and Samraj and myself here in the Bay Area, and Carly, who is actually in the background, bringing us live to all these different platforms, is in Florida. So guys, you guys want to say hello to the community, Serena?
Hi everyone, nice to meet you. I'm Serena from MLflow team.
Hey.
And
everyone.
Yuki?
Yep. Hi everyone, I'm Yuki. I'm probably like 4 or 5 times here in the MLflow webinar, but yeah, nice to meet you guys again.
He's a frequent speaker here, which is great. And then Samraj, obviously.
Yeah, nice to see everyone here. It's my second time here. Excited to share some features.
Thank you. We actually have a packed agenda today, so I'm going to quickly go with the logistics today. We're coming live to you on 4 different platforms, at least 3 right now. X, we got YouTube and LinkedIn. So wherever you are joining us from, please do let us know. Put something in the chat where you're hailing from. We have a global community, and we're always interested to find out where people are joining us at what hours of the day. Some of them are in the morning, some of them are in the afternoon. So we're always delighted to get surprises from people at 3 a.m. in the morning who actually are quite eager and curious to know about 3.9 release. We can't hear you, unfortunately, but however, we do recommend that you putting your questions in the chat, whatever channel you're dropping from, and then we'll try to answer all your questions toward the end. What we'll do is essentially go straight to the to all the presentations and then reserve the last 10 or 15 minutes for Q&A. A bit, you will have lots of questions. So here's a quick agenda. We're going to start with Yuki, who's going to kick off with this really exciting feature that we have added to 3.9. He'll tell you all about it. I don't want to burst his bubble. And then we'll get a lens into how we can actually look at performance matrix and figure out, how much does it actually cost per tokens as you're actually experimenting and developing your agent from Serena. And then we'll get a good glimpse into what are some of the new features where you can actually do judge builder, do continuous monitoring, and also the new feature called MemAlign, which dynamically optimizes your prompts or your agent. And then Yuki will come back, or the team will come back, and then give you a quick peek into what to look forward in 3.10, which will be coming up in a couple of weeks. And we might have a similar webinar, most likely 3 weeks from today on February the 25th, same time. So do join us. With that, I'm going to hand it off to Yuki, who's going to kick off and tell us all about the MLflow assistant, how you can use it and what you can do with it. So Yuki, take it away, please.
Sure. Thanks for the introduction. And do you want to introduce this slide, by the way, Joe?
Yes, I forgot about that. We have a couple of upcoming events which are coming up in the Bay Area and in North Pacific Seattle. These are in-person meetups where we're going to be talking about AI observability. 3.9 has introduced a lot of packed features that allows us to actually give you a lens into how your agents are working. So one is on February 17th here in San Francisco at Databricks office. So if you are in the Bay Area, if you're joining us from the Bay Area, do pop in. I'll definitely would love to meet you and have a conversation with you. And then if you are in the Pacific Northwest, 2 days after that, February 19th, we'll be there. So do keep those things in mind. We will record these sessions and we will share with the community if you can't attend it, or if you're different parts of the world, oceans and lands away. But definitely if you're in the Bay Area or if you're in Northwest, do join us. And this is a way to get connected with the community. We have a Slack channel, GitHub. Please visit us and give us a star if you actually like us. We also have Luma calendar that you can actually follow us. And then we are on Slack and on LinkedIn. So hopefully you can actually reach out to us through any of these particular channels. And then I think with that, it's Yuki. Take it away. Thank you for reminding me.
Sure, no problem. So I'm going to introduce a feature called MLflow Assistant today. That was released in 3.9, and I'm going to start with this slide. Yep. So starting from the problems, like why we added that feature. So when you use MLflow, we you guys like get a lot of questions, right? So you spin up MLflow, but where do I get started? And also MLflow UI has many features, many features like traces, experiment, models, prompts. So how do I use that? And also after you onboard it to MLflow, maybe get the first trace logged in or maybe first run, then what do I do next? Also, there's a lot of things you can do with data you logged in MLflow, for example, doing evaluation using MMJudge. But how do I do that? Then also, it's not only about like MLflow features, but the data itself. You have a lot of questions, right? So, for example, what your trace might show some errors, and like you might want to like find the root cause. Also, we have like some new dashboard feature which Serena will introduce, and then you might see some spike of token count. Then you wonder like, what actually caused this token spike. So we have all of those questions in MLflow, and of course we can find answers in documentations or manually reviewing your data, or maybe go to some tutorials, but it is not super easy. So that's why we added the solution in MLflow, which is Claude. So Claude, I don't think I need to explain that. It's very popular, but basically it's a coding assistant built by Anthropic, and it has a lot of powerful capabilities. Like, of course, it can write code, but it can also do web search. It can do using some more main tools. It can do some like automation or so. This is kind of powerful and harness built by Anthropic, and we integrated this into MLflow natively. So when you open MLflow now, you will see a panel on the right saying, "Hey, welcome to MLflow Assistant." This is actually powered by Claude Code under the hood, and this feature solves a lot of cool questions we had in the problem slide. So let me just do a quick demo because it's easier to showcase than like describing in my English. So, yep. So here's my experiment. I'm spoiling the Serena's part because this dashboard itself is new, but please take a look at this side right now. So this is an MLflow Assistant. So in order to start, you actually need to connect with Claude Code. So you need to actually go through the setup step. But basically, you choose a provider, which is Claude Code only, but there will be more providers. Then click continue. Then MLflow checks connection with your Claude Code. You will need to install Claude Code, but this basically checks you have Claude Code, you have logged in, or other like setting up. So once it's done, you can continue and set up a few things. And I'll put some project path here so that Claude Code knows where my code is in. And yeah, there's a few things you can configure, like permissions or skill location. But anyway, I just finished the setting. Then now you have this chat view. So this just looks like the normal chat bot, but there's a few different things, kind of unique things in MLflow. But let me showcase one use case. So let's go to one of the conversation. So this is all the sessions, right? Basically, the traces with conversation in this experiment. Let's go to open the one trace session. And then you can ask a lot of questions like, hey, summarize this session, or what is the outcome, or identify issues. And since MLflow knows about where you are, what you are looking at, this session is already passed to this Claude Code context. So you can, for example, click identify issue in this chat. Then MLflow automatically pulls data about this session and analyze and identify any user frustration or performance bottlenecks or whatever. It takes like 12 or 30 seconds. So I just skipped to the pre-generated one to save time. But basically, after doing multiple tool calls and skill execution, the assistant comes up with analysis result. And in this case, it seems like there's some hallucination. It shows some non-existence API about prompt, and also it's repeating the hallucination even after user is asking about the clarity. And yeah, finally, there's another inaccurate response for how to use tracing with prompt registry, so which is not great. So the assistant can list up those issues and recommend next step. And you can also, since Claude has access to your code base as well, you can ask fix it too, and then it automatically apply recommendation or maybe ask you a clarification about the approach or something like that. Another use case is just to showcase is like what to do next type of question. So if you actually open the trace and hey, I want to actually evaluate this trace. I have an agent. How do I evaluate this? Then you can ask question like how to measure quality. And then assistant knows about MLflow and the APIs. So it can recommend like what kind of code you want to run, and what kind of built-in metrics or judges, for example, relevance to query or the tones, and summarize what you want to do. So this is pretty good, pretty powerful if you are new to MLflow and want to onboard to new features, because you don't need to go to documentation and find a relevant page by yourself, but you just need to interact with MLflow and just find what you want to do, and then ask assistant directly to what to do. And the assistant can also write the code. So here's a demo, and I just stopped my screen, sharing my screen, and go back to the slide. So just to recap, so what's unique in this assistant? So first thing is it's free because it's Claude. You don't need to pay for anything to MLflow or anything to us. So the only thing you need to have is a subscription to Claude or maybe API keys, but we don't charge anything to use this feature. So you can just free use it by without considering any cost. I didn't see it well, but it's passing GitHub or Roca folder. Okay, let me just pick up some questions after my part. I make sure I'm answering those questions. And second thing, it's aware of your project. So since we can pass the project path, it understands the local code base and then project structure and provide a tailored recommendation for your project, not generic advice. So for example, in my case, it was a tool calling agent. So agent provides so the assistant says like, hey, let's evaluate relevance to query, let's evaluate like some tool things. And instead of saying like, hey, you must do this about in general, blah, blah. So this is more like a grounded advice. Another thing is, so since Claude can actually write code and fix issues by themselves, we can complete the loop in the UI rather than you need to switch between browser and IDE or whatever, like coding editor. So you can just sit in UI and ask questions or talk with the assistant to inspect your code or anything. Basically, the job to be done. And lastly, it's fully customizable. So Claude has a lot of knobs to customize, right? So skills or sub-agent or tools, everything you do in local is reflected to assistant as well. So there's no more black box configuration. You can control everything assistant do by your own. And the setup, yeah, I just demonstrate the setup step very quickly, but here's the official guide. So install Claude using npm or the installation script from Anthropic or anything, and then run login command within the Claude CLI to authenticate. So it can be subscription or API keys. And then go to MLflow UI, open the assistant page, assistant panel, and then follow the setup instruction I went through. And then you're ready to go. So you can start asking questions or talking with assistant. And there's a few more use cases I wanted to demonstrate, but I couldn't because of the time's sake. But yeah, one thing is set up MLflow for you. So go to an empty experiment and ask something like, how do I get started in MLflow, or set up tracing, set up evals. Then assistant pulls the required information from the documentation and provide a guidance for you tailored to your project. Another use case is the bug issued in traces. This is the example I shared to you. So you can open the trace or open a session and say debug error in this trace. The assistant automatically pulls the trace data or session data and summarize the findings for you. And also, assistant can analyze the metrics trend. So now we have a cool dashboard in MLflow, so you can ask about like trend or what's happening under the hood for spikes or any anomalies. And of course, evaluation is important. So I just shared a quick example, but you can ask for how to evaluate your agent or those kind of LLMs questions in general as well. And of course, this is not limited to GenAI. So if you are using MLflow for classical ML, for runs or model registry, assistant is also there. So you can ask questions about your runs or your models as well. And speaking of the customization, I just talked briefly mentioned about skills, but for context, skills is a kind of packaged instructions and examples that tells Claude Code or any coding agent how to do your work, how to do work. So the skills can be like analyze trace, skills can be like automating your work. But in MLflow, we publish the official skill repository that you can install directly into your coding agent, not limited to assistant, but it can be your local Claude Code or Codex or Gemini CLI to automate your work with MLflow data. So basically let the coding agent work with your MLflow data. Yeah, so this is also on live. So you can go to the repository linked here to and install it with maybe Parcel skills package or just directly by copying files or whatever way you want. Okay, so I just demonstrated the assistant, but it's in beta, so it's very early stage. So there's many things we can do from this place. So for example, we want to support more providers, including Codex, Gemini CLI, Open Code. We are not kind of stick to single platform. We are open source, so we want to support as much coverage as we can. So those popular coding agents like Codex, Gemini CLI is our scope. And also one limitation we have right now is it only works for local server. And we are looking at supporting remote server, of course, because we know many teams actually run MLflow in a team. Many teams run MLflow in remote server so that everyone can access to the shared server. So we are looking for the sandbox or sandbox solution to run it in the server safely and also connect to GitHub to understand the context. And lastly, there's a lot of things you can do in Assistant. So we are trying to enhance the use case more and tune instruction and skills to make it more helpful. So yeah, that's basically it about Assistant. So if you please try the feature, and if you encounter any issues or requests, please submit an issue in GitHub in this link.
Thank you, Yuki. That was actually a wonderful teaser. I've been using it religiously and I just love it. There are some questions that will come up, but we'll try to answer them towards the end. I think for time constraint, let's get Serena next to talk about the lenses that we can actually look at how our performance, how our agents are doing performance. So Serena, you want to go next?
Yeah, thanks, Jules. Thanks, Yuki, for the great demo. Yeah. So hi, everyone. I'm Serena. I'm going to talk about agent dashboard metrics today. So let's dive in. Yeah. Today, people use MLflow for agent observability across multiple stages of the development or deployment lifecycle. First, tracing helps users understand what happens in each agent request, how the agent executes step by step, which tools are called, which prompt is used, or where issues occur when something goes wrong. And second, users rely on evaluation to check agent quality. For example, whether the responses are correct, safe, or whether it aligned with your guidelines. And then users can use these results to iterate and improve the agent. And finally, once agents are deployed, users can continuously monitor their performance in production using MLflow scorers or judges, ensuring the agent continues to behave as expected over time. So MLflow is tightly involved in the whole process. While more and more people start to build agents today, the challenge is no longer just about how to build them, but also about how to understand and improve them with MLflow. So agents are not single models anymore. It's composed of models, tools, prompts, everything. Once these agents are running, users naturally wants to understand what is actually happening under the hood. And people may ask questions like, how well is my agent performing? How much does it cost to run it every day? Or which tools or steps in my agent is responsible for the failures? And let's take a look at how we can solve those problems today with MLflow UI. People who have already used MLflow should be familiar with this traces page. So you can take a look at how many tokens is consumed within each trace, or check the execution time column to see if there's a spike or difference in each request. And if you want to know your request volume, you can filter by some time range and check the total number of requests. Also, all of those can be done with MLflow APIs. Yeah, and of course we have these assessments columns, including all the results of your scorers. So we can clearly see there are some great histograms showing the overall scores and the ratio for pass or fail. And you can check how the score changes over time. But apparently it's not super visualized well, so that you don't know the trend over time. And also, if, for example, if you have any errors on your traces, you need to click into the trace to see the details view like this one. And you can see, oh, for example, this search web tool is failing, and then I need to fix my agent on this tool. So all of those are a little bit cumbersome, and we understand our customers are feeling a little bit painful in this process. And that's why we introduced the solution of MLflow Agent Dashboard. It's a new overview tab in the MLflow UI that brings all of this information together. So it provides a unified view of your agent's health, performance, cost, everything, allowing you to understand the most important questions about your agent, all at a single glance, instead of stitching together all the data from multiple places. So the MLflow agent dashboard is organized into 3 main pages. The usage page gives you visibility into how your agent is being used, including request volume, latency, token consumption, and overall cost. The quality tab summarizes both high-level or detailed results from your scorers, making it much easier to understand the overall health or reliability of your agent. And finally, the tool cost page shows how tools are being used within your agent. It can help you quickly identify failures, bottlenecks, or other issues during the execution. So yeah, this is the overview of the usage dashboard. You can see it includes number of traces over time, and of course, latency and errors. So we can directly see whether your agent contains any errors on a certain time period. And of course, token usage and tokens per trace. And all of these charts can be toggled with a certain time range. We support different time range from minutes to like several years. And also you can specify the time unit. Say you can look at how your agent is behaving for the past hour within for each minute, or you can check how it works for the past year in a month granularity. And this one is the quality insights tab. It includes a summary of all the scores that's been running on your traces. It includes it includes everything, so you can see it ordered by the total count, and also includes average value for each scorer. And also we include detailed view for each scorer, including the distribution chart on the left. For example, the completeness scorer, it can have yes or no results, but for this one, all of the results are yes. So you can see the scorer is behaving correctly. And also you can check the moving average of your scorer. For example, if your agent is not performing well on a scorer and you make some changes, you can see this, you can monitor the moving average and see the value goes up. So that means your agent is improving. And lastly, the tool cost tab. We also include this tool performance summary ordered by the total number of calls, and you can also toggle it to sort by different columns. And yeah, the success rate indicates whether this tool is working fine or not. And also we include the token usage over time and latency comparison. For each tool, it contains the error rate monitor, so you can directly check whether some tools are failing or not. All right, so with the MLflow agent dashboard, you can easily spot trends and anomalies in your agent data right now, drill down into specific issues with just a few clicks, and continuously monitor how your agent's behavior improves over time. Yeah, I also want to share some upcoming improvements and features in MLflow 3.10. So people may have already noticed we include token count and its breakdown in MLflow UI right now. And in 3.10, we're introducing the cost breakdown. It supports both trace level and span level. So for this screenshot, it's showing the cost breakdown for this whole trace. But if you look at the single chat OpenAI span, it also includes the information about which model it uses and its cost. And of course, we will bring the cost tracking into our agent dashboard, including this cost breakdown chart that can directly see how much is cost for the selected time range and group by the model name, as well as this cost over time chart showing you how the cost is changing over time. Yeah, so now let's see some live demos. So for this launching new experiment, I already ingested some traces data. So this is the current trace view. You can see we have request response, execution, and assessments. Yeah, so let's take a look at this new overview tab. We can see I selected last 24 hours grouped by hour level, and we noticed uncertain time, there are some requests and the corresponding latency, including P50, P90, and P99. And oh, I see there are some errors. So we support this tooltip that can directly link you from this dashboard to the traces. And this is also the enhancement that's coming in 3.10. So when we click on this tooltip, we can directly jump to the traces view with the selected trace with error state. So it's easier to find errors. Yeah, and also we include the token count and tokens per trace. So let's take a look at the quality tab. Now I have 5 quality here, 5 scorers here, and I have this average value, and I sort by it ascending, so I can see the users uses tools appropriately. Scorer is having a 0.37 score, so it's pretty low. So let's take a look at this scorer. We can see it has like 12 traces with no results. So it's definitely having some problem. So we can click on the tooltip to see the issues. Sorry, it's behaving a little bit weird, but yeah, I will fix it in 3.10. Yeah. And for the tool cost, you can see we also have the summary view. It contains the tools and the success rate. And we can check the search web tool has some spikes, so it's having some errors. And yeah, the latency also demonstrates it's having some problem. So we can jump from the error rate to the corresponding trace. And then we click into that, it's pretty clear that this tool is having a problem. Yeah, so basically that's the dashboard. And also, as I said, we're going to bring cost tracking into 3.10. So for example, we can check this trace. It contains the cost, overall cost, and breakdown at actress level. And when we click into each span, it contains the model name and cost breakdown. So it's pretty clear how much actress is costing. And in the overview tab, we added these two charts. Can demonstrate how your agent is costing over time, and selecting different models and monitor their behavior. Yeah, basically that's all for agent dashboard.
Thank you, Felina, for that insightful lens and the granular lens into everything that's actually happening behind the scenes. I just love the cost-benefit analysis. I mean, I was going about to pop in the question by saying, I want to know how much each span is costing me. I want to know collectively all the spans within the trace, how much actually cost me. And you actually showed that very well. And I think having this particular lens for people who are really data freaks and people who actually really enjoy looking into behind the scenes is a huge addition to the observability. So thank you a lot, Selena. And I'm sure there are questions that have come in. We'll reserve it towards the end. We're going to switch over to Samraj, who's got a lot of the last big features as part of 3.9 MemAlign Judge Builder, which is a great way to do continuous monitoring. So he's going to give us a rundown of what it actually means for you to use this particular feature in 3.9 and beyond. And take it away, Samraj, it's all yours.
All right, wonderful. Thanks so much, everyone. Again, I'm Samraj. I'm an engineer on the MLflow team, and I'm here to talk to you about some of the recent judge features that we've introduced in 3.9.0. And if you're not familiar with what an LLM judge is, it's essentially a way to gauge the quality of your GenAI application, but without the toil of manually reviewing it. So if you imagine you get a response from your agent and you're trying to gauge, hey, is this correct or is it safe? Or if it's using a vector search, did the documents it retrieved, were they used properly in the response, or did my agent just make something up? All of these are forms of judges. And if you imagine having to do those manually, you can imagine it's a lot of work. So we just give that to an LLM, and that's an LLM as a judge. And so I'm going to take you through a couple of features. The first is Judge Builder, which is a dedicated UI for basically building and improving and iterating on these judges. And then I'm going to talk to you about how do you actually get those judges to align with what you think they should do. So in many cases, we have customers come to us and say, hey, I created this judge. It works for me 80% of the time, but the other 20% is just doing its own thing. And so how can I provide my feedback to that judge to get it to do what I want it to do, and so that I can trust my judge? And lastly, I'm going to talk about some changes that we've introduced to enable monitoring so that you can track production traffic using these judges. Okay, so let's hop into Judge Builder. There's a new UI, a new tab in the MLflow UI, and it essentially allows you to create judges, whether it's built-in judges that MLflow offers or completely custom judges that you want to create. You essentially have the flexibility to create judges and then preview them on existing data in your experiment. So in this case, I'm testing out a guidelines judge on a couple of conversations that I've logged to my experiment. And one of the really cool things here is that, again, we offer complete flexibility in the judges that you create. You're able to manage all of these judges that you've created in one place. You can, and I'll talk about this a little bit more later, you can enable monitoring for these judges. So this is essentially your end-to-end workflow for building out judges, iterating on the prompts, and then seeing how the judge actually performs on real data. And so some things I want to call out here. This LLM judge is integrated with the new gateway that we're introducing or have already introduced. And this allows you to basically select any model that you want from any sort of provider. You can enable usage tracking over these models. And so this is a really easy way to plug and play and choose whatever model works best for your judge. On top of this, we support two different kinds of judges: trace level judges, which essentially let you go trace by trace and provide a judgment over them. And some existing examples include our safety judge, our correctness judge, retrieval relevance, tool call correctness. And there's, I want to say, maybe like 20 MLflow built-in judges, and we're always introducing more. And a really cool thing is, as well as all of these judges that we also offer integrations with other third-party evaluation frameworks that you may have used, like Deep Eval, Ragas, Arise Phoenix, and much, much more. There's even more being included in the next release of MLflow. So we support all of these trace level judges, as well as fully customizing your own. We support session level judges, and this means that I can gauge, did my conversation fully address the user's request? That's conversational completeness. Did my assistant maintain its role through the conversation? That's conversational role adherence. And all these other conversational judges that we also offer out of the box. And then again, we offer third-party conversational or session level judges. And lastly, as I mentioned, if none of these work for you, you can always go and build your own judge. And we offer these different template variables that allow you to just completely flexibly create your judge. You don't have to worry about any of like the output formatting or anything like that. And the judge will return any sort of output type that you request, whether it's a string, a bool, an integer, whatever you want. So fully custom. So that's the judge builder. Now, the next thing I'm going to talk about is, once I've built my judge, maybe I find that it doesn't always agree with me, right? And so this is what I was talking about before, where a lot of customers will say, hey, it's not doing what I want it to do, and I just want to give it some feedback and steer it in the right direction. So how do I get my judges to align with domain experts? Or if you're the one building out your judge and making sure that it works fine, how do I get it to align with me, right? And so I'm going to hop into a quick demo here. I'm going to show you guys a notebook I created. A lot of this stuff is just standard MLflow boilerplate. I'm setting an experiment. I am picking out some of the traces, and all of these traces have some human feedback on them for a grammar judge that I want to build out. And so one of these traces, for example, has this human feedback saying this example is a fail. It doesn't have a period in it. The example itself is not so important, but I do have some human feedback on these traces. And I'm building out this judge that essentially reviews the conversation and checks if it has grammatical or punctuation issues in it. And I return pass or fail. If there are issues, I set my model. And you can see an example judgment here. Now, we've had alignment in MLflow for a while, and we have integrations with DSPy, Simba, and JEPA. But what I want to show you here is actually side by side this new alignment optimizer that we've created called MemAlign. And we've worked with our research team to build this out. I'm just going to run this for you guys side by side. So let's go ahead and run the default first, which uses Simba. And so that's started running, and I'm going to run MemAlign on the side. And there you go. Looks like MemAlign's done. So I'm going to talk a little bit about MemAlign while Simba goes ahead and finishes, and we'll see if it finishes by the time I'm done. MemAlign is this new optimization technique that our research team has developed. It essentially relies on two memory mechanisms. One is called semantic guidelines, and the other is called episodic. Semantic guidelines essentially takes that human feedback that you saw me provide, like saying, hey, this example doesn't have a period in it, so it's a failed judgment. And it'll go and distill those into guidelines that the judge will go and use and refer to later. Episodic memory is sort of the way that it remembers specific examples. And so when a MemAlign optimized judge sees a new example, it'll look into its episodic memory, find similar examples. That's what this retrieval K is for. And then it'll use those for its judgment. And down here, you can actually see the results of MemAlign. Simba is going to keep on running, but luckily I pre-ran this before, so we can compare these side by side. And you can see that MemAlign took and on the other hand, big bump in accuracy, but only took 0.01 seconds. So this is a massive, massive speed up. And we have a blog that we've posted about this and more information as well to come soon. But the key thing here is that MemAlign adapts dramatically faster and cheaper. We have comparisons here against the common DSPy optimizers, and you can see that blue line, MemAlign, does not, the cost stays pretty constant no matter how many examples you're using. The latency stays pretty flat no matter how many examples you're using. So, and on top of this, lots of charts here. The big takeaway is MemAlign's quality does not drop despite these improvements. So even though MemAlign's much faster, you're still getting the same quality guarantees. I would be remiss if I didn't talk about the benefits of Simba and DSPy in general, because it is also a great prompt optimization framework. And so some of the downsides of MemAlign are that there is an additional vector index cost during inference, which can, maybe cost up to like half a second to a second. So if you're super sensitive to judge latency, you might want to consider the DSPy library. So that is MemAlign, the new research-backed method that we've introduced, and a big kudos to our research team who's put a lot of work into that. The last thing that I want to talk about is continuous monitoring. And this is essentially how you make sure that your agent or your GenAI application is doing what it's supposed to do when you deploy it in production. So if you're familiar with traditional software engineering, you typically write your code, run it locally, test it out. You write unit tests, you do integration testing, but once you're in production, you need some form of telemetry to make sure that your entire software or your application's not going haywire. And the same holds for any GenAI application. The equivalent for GenAI, in addition to whatever telemetry, operational telemetry that you have, which MLflow also offers, is monitoring with evaluation. And this is critical for your production story. So in that same Judge Builder UI that I showed you guys before, there's a section called Automatic Evaluation. And here you can select to run your judge on all traces flowing into your experiment. You can choose how many of those traces you want to evaluate on based on the sample rate. And this is configured per judge, as well as a filter string. So you can filter certain traces that you want to evaluate. For instance, in this example, we don't want to be evaluating traces that have errored out. So we're just running on traces that have the status okay. And once I create these, it's kind of hard to demo because this is something that runs in the background as traces flow into your experiment. But I have two assessments here set up with monitoring, faithfulness, and user frustration that you can see on the right-hand side. And as these traces flow into my experiment, it doesn't technically matter where they come from. It can come from my developer, it can come from production traffic, but as they flow in, they're all getting evaluated automatically. I can see the evaluations. And then this ties back to Serena's presentation about the dashboard, where now I can track the performance of my agent over time. So this is super, super powerful. And for anyone with a GenAI application in production, this is a must-do. And yeah, that's all for the sort of story of what we've released for judges in 3.9.0. There's more to come in 3.10, and I think Jules and Yuki will take it away from here.
Well, thank you, Samraj. That was actually a wonderful glimpse into what MemAlign can actually do. Yuki, you want to somehow briefly give us what's coming up in 3.10, just as a teaser, for a couple of minutes before we go into the Q&A? Carly, we seem to have lost the slides.
Yeah, I have it in my local, so it's, let me just open it. Yep. Okay, yeah, I can do that, Valerie. Then, okay, so in 3.10, we have a lot of features as well, as much as 3.9. But speaking of the judge, we will have a, so now we have a great judge, great way to basically evaluate traces or conversation. The question is how, so where do we get the traces? Of course, you can get from like manual testing or production traces. But in 3.10, we will support the multi-conversation simulator. Basically, that simulates the interaction between your simulated users with your agent, so that we can get a very realistic conversation in a high volume to use as for evaluation. So that we can that's the comes in 3.10. And also, what as Serena mentions, we will have a cost tracking dashboard. So it's not only about token count, but you actually have a real dollar cost visible in the dashboard. And another exciting thing is the feature called Workspace. Oh yeah, here it comes. Thank you so much. So the south thing is Workspace for organizing experiments. So currently, MLflow, the top level container is experiment, but we've had a lot of feedback about can we have another level to organize experiments further. So finally, we support the feature called Workspace to have a governance over multiple experiments. You can actually group experiment into Workspace and manage the access or govern the usage within the Workspace, so that you can use a shared server between multiple teams and without like mixing people. So this is actually the big contribution from the contributor from Red Hat. I want to kind of say thank you to the to Red Hat, but also I think we will have the collabo session in the next launch webinar to talk about this feature more. And lastly, so we added a lot of features, but yeah, we also want to kind of make it very easy to test new features. We are adding a lot of features. It's very hard to catch up all of these features. So we will, in 3.10, we will introduce a demo experiment, which has all traces data, eval data, prompts, or all the features, all the kind of pre-generated data for you to try out new features in a minute. Yep. So these are only a few pieces of the 3.10. So there will be more features. But yeah, also to see the full roadmap in the 2026, please visit this roadmap discussion and give us feedbacks. And yeah, again, if you're excited about these features, please give us a GitHub start.
Thank you. I think this is an exciting 3.10 features coming up. It's going to be as packed as 3.9, and we're going to have a webinar. We'll have all the respective contributors from the MLflow team walk through it and share with the community what we have. I think we're going to take some questions from the community if both Samraj and Serena can come on back online. So let's see here what we actually have. We have one question from Ravid Singh. Can the MLflow assistant be traced in MLflow? Can MLflow assistant be traced in MLflow? That's interesting. That's like a circular thing, isn't it?
Yeah, that's a great question. So right now, it is actually possible if you set up the MLflow Claude code tracing. So we have an auto tracing feature for Claude code. So if you set up it locally, so currently the knob is in log, so in CLI. So you need to actually run MLflow autolog Claude. I guess that's the correct command. Before setting server, then you actually start automatically traced. And the fun thing is that actually how we tested or evaluated this assistant feature. So we use that a lot in internal development to see if assistant works well, if it is called right tool or right skills. I think it is pretty much possible to have that knob inside UI, so you can set up history. So that's definitely one feature we can consider. But yeah, this is a great question.
Yeah, but there's actually, but that ask or that particular issue, does it actually solve any particular problem by having the MLflow assistant be traced in the MLflow traces, or is it mainly for curiosity to see what is the MLflow code doing?
Maybe or may not. Yeah. Maybe
Yeah.
it is for customization, or maybe to
Yeah.
get some visibility for curiosity. But yeah, whatever reason, I think that's a great.
Yeah. Yeah. Sarina, a question for you. I think the cost things that which are coming in 3.10, somebody actually was curious to know, at what point do the cost are displayed? Does it actually happen in real time, or is it after the fact that the span or the trace is finished, and when you go back, it actually calculate the cost? Or does it actually happen in real time? Can you actually see the dial going up and down as one trace is finished, or one spas is finished, the cost goes up? Can somebody actually look at the UI in real time to see it?
Yeah, so when I think MLflow UI currently supports in-progress traces,
Mhm.
and after each span is generated, the cost is generated. So you can see the cost on that specific span, but for the overall cost of the whole trace, it requires all spans to be ingested. While
Okay.
for the cost tracking dashboard, yeah, as long as one trace come in, you can refresh that dashboard and it will show up the latest
Okay.
data.
Okay. Okay. I think this question is probably generally for the behavior of any particular judge. This particular person asks, where is it? I would like, Amin from Delaki asks, I would like to know how to ensure that agents will perform as we expect from them. And I think this is to some extent, Samraj did answer about that, but I think it's a good question. How do I ascertain, or how do I ensure that my agent is behaving or doing the right thing? To what degree do I actually get the confidence in all the judges that we actually provide? And you mentioned something that one way to find out if the agent is behaving the way I want it to behave, which should really talk to this particular question. So Samraj, do you mind taking a shot at it?
Yeah, I mean, it's a good question. It's a very hard question. I think this is what everyone wants to know the answer to.
Mm-hmm.
This is the goal behind evaluations in general and setting it up for your agent. I think the most critical thing is being able to express what you expect from your agent. That's typically the first step in any sort of agent development. And basically how we think about it as eval-driven agent development. So a lot of people struggle with understanding what they actually want out of the agent. There are oftentimes a lot of edge cases, a lot of domain-specific knowledge in your agent, and you have to find a way to encode that into your evaluations. And whether that means in your judges, which might assert domain-specific things, like if I'm building a financial bot and I want to make sure that it doesn't give financial advice to users, I need to have a proper judge that expresses that constraint in a way that, you know, a 5-year-old could understand, because an LLM is a very simple thing. It's very direct.
Mm-hmm.
There's ambiguity that makes evaluations hard, both for humans and LLMs. And then once you have that set up, Yuki's demo with the assistant is a great way to get started with evaluations. It really just takes you through the entire flow. And then as you kind of get more and more advanced, you can start building on some of the customizability of MLflow to really get the confidence you need in your agent.
So in other words, I mean, the built-in judges and all the integrations of the third-party judges that we actually have, which, you know, amount to over 70, those are good standard expectations, standard behaviors that you would actually want your agent to perform, and you can measure it against those metrics. But as you pointed out, I think to comprehensively understand or to comprehensively get close to, is the agent doing what I'm supposed to do? That's where the subject matter expertise comes in, and that's where the custom judges come in, right? And you talk about writing the custom metrics that you can actually do, and also add more judges as you begin to realize that the agent didn't do what I want. So here's my new custom judge, and here's my human feedback that allows me to actually do that. Brilliant. Question for you, for Yuki, from David Gins. Does the tool calls in agent trace also include MCP calls? Does the tool calls in the agent trace also include MCP calls?
Yeah, I think for most
Yeah.
of the frameworks, it does. For example, if you use LangGraph, if you use DSPy,
Yes,
MCP code, or
yes,
other
yes.
tools, if you're building like custom code, you can also like insert a decorator to make tool calling like show up in the trace. So yeah, that's sorry.
I mean, currently the MLflow assistant, as you said, is looks at your code locally. Does it have the ability to actually look at your code outside? I mean, can you actually provide it as a GitHub repository to say here, here is the extra code that I want you to look at?
Yeah, that is what we are thinking as configure. Of course, you can always like give it that interaction like in the local like Claude like prompt like system instruction, but it doesn't support it natively in the MLflow UI. So in the bucket of remote server support, we're actually thinking that one way to give give assistant more context about your code, because now we can't access local codes, and yeah, we need to connect it to GitHub or whatever place that source code within.
So Serena, are there any other metrics that you think that people would want to really look at besides the one that we actually have in 3.10 or beyond? I mean, what are some of this is the general question for anyone. What would be some of the metrics that if you actually had to say, I really want to know right off the back that this should be monitored, this should be something that I should really look for?
Yeah, I think that's a good question. And we also want to know from our customers. So if
Mhm.
you, for example, custom dashboard, if this is something you want to have it in MLflow UI, please raise an issue and we can see how many people vote on that. And we can consider supporting custom dashboard. And
Thank
yeah,
you.
to mention that cost
Mhm.
dashboard is something that we saw on our GitHub repo. So we
Yes.
prioritize that.
Yes, and that actually had come up quite a bit in times at talks as well. I really want to see how much is my trace costing. I want to see collectively the granular how much each span is costing, and I will be able to somehow then say, okay, I'm going to switch off to a different model, or I'm going to distill more, or I'm going to use a smaller version of the model. So I think having that particular insight is great, and I like the idea that hey, we don't want to listen to you. So if you actually have some idea that you would like to find out, please let us know. Please file an issue. We have a question for Rahul Bahadur. Is there a way to evaluate more complex agent configurations like Graph or Swarm where the agents talk with each other and complete a task? Or is it limited to initial user input or final output? And I think it's probably referring to, is there a way that we actually support agent to agent communication, or a way to actually interact that through MCP?
Yeah, this is a great question, honestly. And this is one of the really nice things about MLflow, which is complete flexibility. It doesn't
Mhm.
matter what you're tracing. It doesn't matter what aspect you want to evaluate. One way or another, it is possible. So with a graph or a swarm, you have separate agents. Each of them are producing traces.
Mhm.
And in those traces, you can evaluate certain tool calls. You can evaluate
Mhm.
steps. Among all of those traces, you can also evaluate how those traces interact with each other and sort of how they behave. That's similar to the features that we're going to be releasing in 3.10.0 for conversational evaluation.
Mhm.
But again, any way you want it, there is a way to do it in MLflow. So
Yeah. So when he's referring to the graph, I'm assuming he's referring to the strands as opposed to the traces, right? Because there's a subtle difference between an agent which is built with strands in mind, where you're actually looking at the execution path, which is what Rahul is referring to, and then what we're doing is the tracing part, which we're looking at the spans. So that's what you're referring to, right? In saying that you look at the execution path to find out. Yes,
exactly.
Yuki, you were going to say something. Oh, you disappeared.
But there are a lot of libraries that offer ways to implement graphs and swarms, which are more deterministic ways to implement your agents. So it's a very common pattern and one that we aim to support as best as possible.
Okay, we have a question from Elise who's saying, is the cost tracking feature already available on GitHub master branch? I think we have a branch cut out for 3.10. Serena, do you want to share what the branch name is?
Yeah, actually it's a stack PR, but yeah, I will merge it very soon. So
Okay,
yeah.
okay. So
It will
you
be on
see,
master
yes,
branch.
yes, it is in the, it'll be soon in the master branch coming. It is under PR review, so you should be able to actually pip install, do a git clone, pip install it, and you should be able to see that in your UI.
We also
Go ahead.
we also do a release candidate next Tuesday, I guess. So we will have a MLflow 3.10 RC. So please, I think the cost tracking will definitely. So please.
Oleg Miko asked, do you have any timeline for 3.9 to be available in Databricks? This morning I did try the DBR 18, which is the released version of it, and it has 3.8.1 installed, but you can actually go ahead and install yourself. So if you just do a pip install of 3.9, you will have all the features available in your DBR version. And one of the good things that you can actually do is you can do a pip install on that. So you can do that. As opposed to when it will be available, it should be available very shortly because we just released the release, and it goes through a release cycle of testing before it actually goes on DBR. Let's see. I think those are all the questions. Oh yeah, one question, Samraj, for you. I think you did a show, and we're actually running out of time, but I'll I have the mic, so I won't drop it. One thing that actually popped in my mind when I was looking at your demo, comparing the GEPA and the Simba optimization and the MemAlign, and it was quite fast. But you do mention with caveat saying there are certain use cases where one is better than the other. Well, MemAlign might not be the right one, and Simba and GEPA might be the right one. Could you be more specific and more concrete to give me an example where I would want to use MemAlign for optimization, and when would I actually want to use GEPA? Is one more for prompting, or the other one is more about the execution?
Great question. So both take in essentially a set of feedback and provide an optimized judge. But the underlying infrastructure of the judge differs between the two. And there's an additional component with MemAlign optimized judge, which means there's a little bit of additional latency. So in latency sensitive scenarios, for instance, I'm using my judge as a guardrail before I return a response to the user in production. That's a place where I might want to use the DSPy optimizers because they're just providing an optimized prompt. But in evaluation, for instance, when I want the highest quality judge and I want to be able to iterate on it very, very quickly, and this is one of the cool things about MemAlign is that it's going to unlock a lot of UI powered alignment. When I want to do that workflow, then MemAlign is a great fit.
Great. Well, thanks a lot. I think with all that time, thank you, Yuki. Thank you, Serena. And thank you, Samraj, for the wonderful peek both in 3.10 and all the great things that we guys have done for 3.9. And I'm looking forward in a couple of weeks for 3.10 to repeat, the same way we can actually share with the community all the exciting stuff we're actually doing. So with that, good evening and thank you.